And yes, we were live. I'm sorry for the delay because Zoom has a little delay of 20 seconds. And because this is just the second time we use Zoom for this broadcast, I just wanted to be sure. So you saw me wiggling around and watching the screen, but thank you for joining yet another Virtual Jug session. Well, the Virtual Jug is a jug that is, so its name is virtual. So if you do not have a jug nearby, or you get bored by that jug, or you just want to have more information, feel free to join us because we have the best content and we have speakers from all over the world joining us to talk to you. Today we're going to talk about Kubernetes, but I will first show you some slides because, well, we try to be some sort of, oh, I'm so good at this. You see, I'm trying to share slides and it doesn't work. So I'm sorry for that. First, I need to share this, to use the share button. And then you see my desktop like now. Can you see my desktop, Anna?
Yeah.
Perfect, perfect. So now you probably see a slide.
Mm-hmm.
Cool. So welcome again to the Virtual Jug. First of all, my name is Brian. I was introduced to the Virtual Jug team well, slightly over a month ago. So I'm one of the new admins and I will be hosting this session today. I am a developer advocate for Sneak, and Sneak is a company that provides developers with tooling to be more secure during your development. I also have to mention that that same company is our main sponsor currently because they hooked us up with this Zoom technology. And well, previously we did this on things like Hangouts on air, but Hangouts was discontinued. So now we're using Zoom. So thank you, Sneak, for that. Today's session is about Kubernetes and the 12-factor cloud applications, and it will be given by Anna. And you see her Twitter handle here in my screen. Anna is a developer for IBM, working currently in Romania. And well, she knows a lot about Kubernetes. She is, of course, she's an engineer, and she is a seasoned speaker on the DevOps and Vox events. She's also in the committees for a few of them. So I'm very pleased that she is here, and she will be giving that talk. During the session, we are available on Slack. Slack is our main communication channel, and if you have any questions, please go to the live sessions channel and ask your questions, and I will redirect these questions to Anna once she is, well, once there is an appropriate time for that. Please share all the content you see here with your friends, family, preferably both, on any channel you like. If you have any feedback, well, you can ping the Virtual Jug or me at the other Twitter handle. For the best resolution, go to the settings cog in your YouTube screen and set it to 720p because we are broadcasting at 720p. That's all for now. So I will stop doing this, stop sharing my screen, and I will give all the answers to Anna. Anna will tell us about Kubernetes. So let me just show that. Now you're on screen. Anna, welcome.
Hi.
Have you here?
1 sec to share my screen. Okay, so let me just minimize this one. Hello, everyone. I am happy to be here. It's the first time ever with a virtual session. And I hope it all goes well. So please bear with me and be kind with me since this is the first time that I am doing this with such a broad audience. So as Brian already introduced me, I would like to add a few more things. I am a custom application development enthusiast. My main focus is on Java frameworks and IBM Cloud. I'm also involved in sharing expertise in the Bucharest software craftsmanship community that I co-founded together with my colleague, Victor Rentea. He also presented at Virtual Jug a few months ago. And mostly we're activating in Romania, and we're spreading what we know in our own language in Romanian. So Bucharest software craftsmanship community is mostly about people that speak Romanian. In today's presentation, I want to share with you a couple of things about Kubernetes and how it complements the 12-factor cloud applications. Those being said, well, firstly, let's talk about what 12 factors and Kubernetes. Well, there are a few things that are of interest for us when we're working with cloud applications as developers. And one of those is the fact that we want to have a smooth evolution of our project. And we're normally doing that by automating our setup with a declarative format. And Kubernetes is very good at doing that, even though that, let's say, we don't like YAML files that much and configuring those. There are ways of tweaking those without much of developer work, but we do need to know the API in order to tweak that accordingly and have a good evolution of our project. Secondly, we want to be able to run everything at push of a button because we want to scale up our projects with minimal changes. So we don't want to have changes in terms of tooling, architecture, when our project is growing. We want to have a smooth evolution, a smooth setup that is going to be very beautiful and harmoniously grow. Thirdly, we want to achieve portability of our project across not only just environments of executions, but maybe across cloud providers. And I'm sure that many of you have heard the idea of multi-cloud and having things across multiple clouds. So this is where Kubernetes is very handy because a lot of cloud providers have offerings with Kubernetes. Having this underlying clean contract between your application code and the place where you're deploying your application has become easier and easier nowadays. Thirdly, we want to have less differences between our local and our production, not just because it's much more easier to identify issues when our local is exactly like our production, but also because we want to achieve continuous deployment. And continuous deployment is not just a very beautiful DevOps thing that we are very interested to know about and to set up because it's nice to have. It's also because we want to propagate our changes across environments as smoothly as possible, as in a short time. So we want to see our critical changes, our not so critical changes, reaching our end users as soon as possible. All these four things are very important for us from 12 factors point of view, and also Kubernetes boosts all these. Those being said, let's look at the scenario that we're going to take into account today. So for today, we are looking to application that is deployed in a Kubernetes cluster. So it's the Dream Home application, which is a very basic application having a front end, which is based on Node.js. This front end connects to two backend microservices. One is for brokers and one is for properties. Basically, what our application will do, it will be the fact that you can add properties managed by a broker for selling or for renting. The data is persisted in Cloud databases, and you see here a managed services. We have just one managed service instance, but we have two databases, one for each microservice. So just to be clear, it's just one service, a software as a service, but with the purpose of instantiating multiple database instances. The Docker images that are going to accompany our applications are stored in a private container registry, which is also a managed service. And of course, for streaming logs, I will use an IBM log analysis service, also a managed service, which is very cool to be used. And at Factor 11, I'm going to share with you why I preferred that scenario and not rely on some other ways of streaming logs. Those being said, let's jump to the Factor 1. So the Factor 1, well, we always start our applications with code base, right? So we want to have one code base in revision control with multiple deployments. However, earlier, I think I showed you 3 applications, right? So 1, 2, 3. It's quite a lot. But the Factor 1 speaks about one code base in revision control with multiple deployments. So in case of a distributed system, each of those code bases has to comply with the 12-factor methodology. This means that every application there has its own code base, its own Git repo, from which we can initiate multiple deployments in different namespaces. Now, from Kubernetes' point of view, the so-called environments of deployment are named namespaces, and they are an aggregation of Kubernetes resources and objects that help our application to live very nice and neat. And how we can achieve this in Kubernetes? So just keep our code base, never touch our code base, the one that we have so greatly created, but just tweak around with Kubernetes configurations. Well, for this one, I'm going to jump into using directly the Kubernetes package manager, Helm. And what Helm does is that you can use Helm charts to describe your code base. So Helm charts are a set of templates that can be combined together with values. And those templates and values can be later used for installation in the desired namespace in the Kubernetes cluster. So this is a much more easier way to parameterize per need our deployments. The Helm install command is receiving as parameters the chart name, the name of the release that we're doing, the application release that we're trying to do, the namespace where we're trying to deploy, and of course, the values that accompany those templates over there. All this time, so I'm going to show to you how to use Helm from command line from my computer. But Helm is behaving similarly in a pipeline where the client is being managed by the pipeline and is communicating with the tiller, which is the server side of Helm, in order to install the charts in Kubernetes. And I want to make sure that you understand that this kind of setup here is only available for Helm version 2.xy, because with version 3, this part here, tiller, is going to go. But we're not going into details with this one too much because I don't want to bore you a lot with this. We can talk about Helm afterwards. And let's go into making the factor 1 for our first application. So let's go here to the command line. Hope that this one is pretty okay for sharing. Yeah. I'm just gonna go a little bit upper. Wait. Okay, it's perfect. So let me go to my first repo, which is the broker. And I'm going to create the Helm charts for the broker microservice. So I'm going to issue the command Helm create broker. Let's just see what was generated. I'm going to go to broker and say tree. So you see here that was a set of files that was generated and folders and quite a hierarchy here. So we're having the chart.yaml, which is the description of our charts that we're going to use for deployment. Charts, if we want to introduce additional charts when we're making the release of our application. And of course, templates that we're going to parameterize with one or more values files. So let's go to the IDE, close all these things. Okay. It's not. It's broke. Okay, it appeared. It was a little bit slow. I was worried. So this is by default generated by the Helm create command. So we're going to modify this to get something more meaningful for us. So we're just going to say a Helm chart for broker microservice. There's also a set of values that's being generated by default. So this one is taking into consideration deployment of an Nginx application, but we're not going to use this one. We're going to use something that I already have created before, my set of values. So my set of values is describing the deployment of my broker application. Let me make this a little bit bigger. So my broker application, I want to deploy one replica of this application because I'm going to pull an image from a private image registry. I'm going to use pull secret that I already have created in my namespace. Also, I'm going to specify the name of the image that I want to use for deployment, a pull policy, the container port, and also because, as you have seen earlier in this scenario, I'm connecting to a database. I need to get some credentials for that database. And I don't want to hard code credentials, neither here and neither in my application code. I just want to smoothly propagate information across configurations in Kubernetes. So what I'm going to do, I'm going to reference in the environment the variable called database credentials that gets its information from a secret called binding cloudant from the key binding. So all the information regarding my database connection are going to be obtained from there. And of course, this in the code is being translated into the parts with the resources, which is very easy here in Spring Cloud Kubernetes database secret database credentials. And this later on being consumed in the Spring Boot application and parsed and used further. So there is no way that I'm sharing secret or very important information in the configuration files of Kubernetes. I'm just basing myself on what's in the environment over there. Secondly, I want to expose my application using a node port service in Kubernetes, and I'm going to make it accessible for exterior on 31270, let's say. And now I'm going to modify the template since I'm done a little bit with the values over there. For the deployment part, I have a lot of Go templates already generated for myself. Yet I don't need all these. So I'm going to clean a little bit on this one. And I'm going to use my own deployment file. And I just want to use this one because it was not okay. This is why the IDE helps me a lot because it signals to me what's not okay. And I can see what's deprecated or not, also in terms of Kubernetes. So all these being said, this part here was already generated. But I also added my part regarding the environment. So this one was for the connection to the database. So where I'm getting the database credentials, how are they going to be named, and everything else that's now specified in the values, I'm getting this here in the configuration of my container. Secondly, I want to go to the service part. And for the service, I'm also going to use my own configuration. And I'm just parsing everything here through the templates, and I'm just reading it from the values, from what I already configured in the values part. And putting this into it, and I'm separating each Kubernetes object with its own concern. So the deployment file gets deployment values, the service gets service values. However, Helm is not just about templates that are already built in. You can also create your own. So I'm going to create my own config map template. And because this is one that's very easy to work with, so I'm going to say config map. And I need to give them a name for it. And since the good practice says that I should not hard code things, I'm just going to say config map here and say name, content, broker config. This is my name. Going back here and just simply using values.configmap.name to get my name. And I want to expose the node port for consumption for other services available in the namespace. So what I'm going to do, I'm just going to go and say .values.service.ports.node port here. So this is for my own customized config map template that is going to be installed all together with the other templates using the values that I provided over there. So now let's go and make the installation of our applications. I'm going to say helm install as shown earlier in the slide. So helm install with the name, let's say hbroker. I'm going to say, well, from the broker charts. And of course, I need to use in the namespace dev. Okay, so let's check the status of the entire release. So helm status hbroker. Perfect, it's running. Let's just check on it. This is another release of mine. Yeah, I was having some emotions earlier when I saw nothing. Just a small tweak in the internet. So everything's done, it's being deployed. Easy peasy, it worked like that. And the same templates can be reused. We just need to create another set of values here, as said earlier into the presentation. And we're just using another values.namespace YAML, and that's it. We're making multiple deployments with just the same code base. Now, it was pretty easy. We deployed just an application with Helm, so we're done with one. But it's not that easy. Now we're going to go a little bit more into details of how we're tweaking all these things, because we went a little bit fast. So we're going to look at the factor 2 regarding the dependencies. That says that 12-factor applications should declare and isolate dependencies explicitly. What this means is that, for example, for an application that is Node.js based, is isolating dependencies would mean to declare your dependencies here in the package.json. This is just a small portion of the package.json I have, so that you can see how you isolate dependencies. This is for the application level. Similar, it happens for the Java applications in the pom.xml file. Now, this is concerning the application, but if we're looking a little bit upward from Kubernetes point of view, we're having dependencies being isolated in an explicit way, dependencies between Kubernetes objects, because this is what we're interested in, how we're isolating dependencies between our Kubernetes objects. So we're doing that using labels. And for example, we're defining labels at the level of the metadata here. So in the deployment object, there are labels defined in the metadata. You see here there's the app and the tire specified. What these labels are actually for isolating, isolating the deployment object and saying that, okay, this deployment object is being described by these two labels. This is being specific for the metadata of the deployment object itself in Kubernetes. Next, we have labels at the specification level. And as you can see here, this one says selector, match label, and the app name again. These type of labels here are useful for the discovery of what we have deployed there for application for the services. So this selector is going to be used for matching what's inside the pod with the service, so that it can be accessed by other pods and again access to the information there. Secondly, there's also labeling at the level of the template. These labels here, also called metadata labels, similar to the ones above, right? Now, the difference between the ones here and the ones here is that these labels are regarding the pods. So these labels are being pressed into the template of the pod, and not the pod object, not the deployment object. Of course, they are all connected between each other, because we need to be able to track each other in order to have a coherent existence in the cluster. But again, they are addressing a specific need, and they're isolating a different type of dependency in Kubernetes at level of infrastructure. Those being said, let's go a little bit and look and make a deployment with labels for the broker microservice using a simple deployment file. So we're going to go here into the IDE. Let's go over here. This is the deployment. Okay, so let's go and use the deployment part. Let's make it bigger. So I'm using the deployment object. I'm going to name it, say, broker. Also, I specified there that there were some labels, right? So I'm going to say labels, app, broker. Again, describing the deployment object here. These are the labels of the deployment object. There is the selector for matching the broker application for the services, the match labels broker. And of course, the ones for the template for the pods, because I want to describe also what's inside the pods. So I'm going to say the tire is backend and the implementation is Spring Boot. Okay, and then I am going to down, and I'm going to describe a service that I'm going to need to access, that I'm going to use to access my deployment here. I'm going to say 74. And of course, the selector being used is for the application broker. Going again to the command line, and this time we're using the standard Kubernetes command kubectl apply -f deployment YAML in the namespace dev. Great. So those being said, let's go and connect in the browser. So it should be 31274. So 31274. Voila. All good. So going back to the presentation, now we're isolating the dependencies, and we saw two ways of deploying a microservice. However, the Helm part is bringing an advantage of reusability. This one, it would mean defining multiple deployment files for each of the places that I need to reuse that. Going a little bit further, we've seen some more configurations there. So we've seen configurations specified in the environment. So that database connection that was done to the Cloud database was involving a secret. And what the third factor in the 12 factors, third factors methodology says is the fact that you should be using the configuration you should be storing in the environment. So those being said, that we should store our configurations as secrets or config maps, depending on the level of security that we want to put in those configurations, and consume them from the environment. So for example, when storing configuration in the environment for pulling the images for Docker, the Docker images from the container registry, I need a secret to access securely that container registry. So what I've done, I created I created a secret for the Docker registry access. This is a pretty standard command. And you can have the same secret name, but defined across multiple namespaces in Kubernetes, and using different namespace, different registry namespaces in a Docker registry. So you can tweak a little bit that one. The only important part would be, in my opinion, to keep the secret name consistent, and in order not to have confusions when using it in deployment. So not to have a discrepancy between the image pool secrets, like one is rec secret 1 or rec secret dev, and the other one is rec secret simple, and you don't know where you're getting the credentials or why some things not working for you as expected. And those being said, let's make another deployment by looking a little bit more into detail of the configuration. So we're going to look into deploying the property microservice. Let's go here and deploy this one. So again, let's make it bigger. We're defining our deployment object for the property. Again, the labels, property, backend, but this one has the implementation with microprofile. And you see here the configuration in the environment. I'm getting the configuration for the database credentials from a secret, stored in the environment securely. And well, I need to specify a node port on which I am consuming this application. So I'm going to say 31276. And because I want to play a little bit more and show a different type of configuration, not just using secrets, and maybe have another configuration that is exposing some information for consumption for other pods in the environment, I'm going to create a config map. And this time I'm going to hard code this. So I'm going to say this one is for the property. I'm going to say front-end property config. And I'm just going to expose the port here, also here, just for the sake of it. Great. Now let's do the deployment of our property. So, 12-factor property. I think I can reuse this. Okay, since they're called the same. But I also want to deploy the config map that I just created. So I'm going to say config map and space def. So now it's everything okay. I'm just making sure 31276. 31276. And since this one is concerning properties, I'm going to say /property. Didn't start. I'm always in a hurry and things are not starting as quick as I wanted. So yeah, these are the list of the properties. I think that's 1, 2, 3 properties that I have stored in the database that I can later use. So you can see that all the time I'm basing myself on the configuration existing outside the environment, and I'm just configuring the minimum for the deployment of the microservice itself. On factor 4, all of what we talked earlier is going to be used into treating backing services as attached resources. So for example, a 12-factor cloud application will always consider a nearby or called local application like broker or property are considered, let's say, nearby applications like the Dream Home app. However, they're going to be seen as backing services by the Dream Home, and they're going to be regarded and consumed from the environment via the network, similar as the managed services that are outside of the Kubernetes clusters. So all the time, we're relying on configurations to consume backing services that are inside the Kubernetes cluster or outside the Kubernetes cluster via the network. And treating backing services as attached resources, simplified, can be seen as follows. For example, if we want to connect to a database, what we would do, well, we would store the, let's say, the database credentials in a secret of type OPAC. I'm going to name the secret called Cloud. So this is just a small amount of the YAML that would describe a secret. And inside we'll have some data regarding the bindings, and call it binding. This secret here called Cloud is going to be found in the configuration and specification of the deployment. And it's going to be seen here as secret QF with the name Cloud. So these need to be the same. And I don't need to look too much into what's the binding having here, because this is going to be processed in the application. So I'm going to use only the key to get the information here and propagate it to the environment later on. And again, these credentials are injected to the application and available in the pod through the environment, which is pretty neat. So now let's go and deploy our last piece, the front-end part, and configure the environment for that one. So we're going to go over to the front end. This is Node.js. Let's go over to this one. Okay. Let's just deploy Dream Home Web. Okay, so Dream Home Web app, which is front-end implementation Node.js, and I think that my image here is not the right one. Just bear with me. I just need to go to the terminal a little bit. I'm just gonna go and use my secret weapon when dealing with IBM Cloud. IBM Cloud CR images to list quickly what I have in my repo. So it's called fed. So in my registry is fed and the tag is 1. Okay, now let's define the environment that environment variables in order to consume the 2 microservices as backing services. So the first one is the broker. I'm going to call it broker ports, and this one is going to be consumed inside the Node.js app. So there's front-end broker from the config map. And the second one is for the property. So property ports, front-end, property config. Okay, and I think I have one more mistake here. Yeah. Again, very useful with the plugin because it says to me if it's a valid or not YAML. And deploy it 31280. And I think I'm okay right now, validated. Perfect. Let's go and deploy the front end. So let's go up, factor event. And I'm going to do a little bit lazy. I'm going to use this. Great. So let me check the 312180. 312180. Wow, at least this one loaded instantly. So this is my application getting 3 properties as described earlier, 2 for sale, 1 for renting, just mock-up data. It's very, very simple front-end app that is adding, deleting applications. It's not very, rocket science. It's just for the purpose of, emphasizing a few Kubernetes configurations. And those being said, we have just deployed 3 apps, and I don't know, what was that? Well, quite easy. Yeah, only if real life would work like that. Well, real life is more about doing repeatedly build, release, and run. So in real life, we're not issuing commands all the time, apply deployment or helm installing manually from the command line. Because we are living in the 21st century and we have a lot of tools that can work and do the hard work for us. We just need to instruct them on how to work that in an automatic way. So in real life, we have the application code and presumably a Docker file that is accompanying that application code. That goes through the build stage. And upon a successful build stage, a Docker image is being created. That Docker image is later pushed to the push image stage, to the container registry. So now we have what to run ready to be run. And we could run it, right? But the thing is that we need another stage to make sure that where we're going to run the output up here is okay and is ready to receive what we have here. So this is the preliminary stage, like release stage in between. That's acting like a buffer. That's checking that things are okay and they're ready to receive this image. Sometimes there are configurations inside the code or inside the Docker file that are done, and maybe the infrastructure is not ready to, to address those. So maybe there are secrets or configurations that are not yet configured over there, and we just need to make sure that these things are happening. So let's go a little bit to the browser, and I think I have the pipeline here. So this is the mirror of what I showed earlier in the slide. It would be like a small pipeline for this one. And if I'm going to the configure stage part, you can see here that, I think I can make this bigger. Yeah, I can make it bigger. So this is the typical script of checking that things are okay. Where you're checking the cluster readiness and namespace existence. So you're checking if the node is available, and this is how you're checking if a certain node is available. Everything is different from master, is available for you to work with. Unless you want to do a deployment on master, but master is almost never available for that. Secondly, you want to check if the namespace is ready for you to deploy things. If the namespace is not there, then it should be created. So you can create the namespace. If the secret for you to access the Docker images is not present there in that namespace, you can choose to create that secret. If you're using Helm, for example, you want to make sure that the server side is initialized. If the server side is initialized, it's not just that. It has to be also configured. So the service account that accesses the tiller has to be configured. The namespace cube system has the right access there. Everything is okay. Otherwise, you might end up with, well, an installed tiller, but with no access to actually do the deployment. And secondly, you can check what was before, if the releases are there and everything's fine. So this is a very nice way to check that things are going okay before doing the actual deployment. Going back to our stuff, if we're checking and we're having a successful release stage, which is typically running that shell script of, checking things. So imagine that you have a bunch of commands that you would normally do to check that things are all right. You just jump there in all of those in the script. Typically, what I'm doing, I'm like saying history, copy pasting, and just, this is how a script gets done. And then there's the run stage. Well, the run stage where you can install or upgrade. Typically, if you're working with Helm charts and you're doing releases one after another, then you would probably want to upgrade that release. So what you can add on top of that installation will create another instance of your application. It might not be very, very good for the economy of your cluster. And this is how you get to a very good run stage. By isolating all these in the pipeline, you get to a very nice continuous way of deploying your code, so continuous deployment, even for one environment. For more environments, there are just pipelines like that, configured even more and just linked all together. Wow, we've done some heavy lifting so far in deploying 3 applications and quite a lot. Wow. But now we're going to look into more about tweaking what we already have done, and we're going to look into some tips and tricks in working with processes. So a 12-factor cloud application typically is an application that is stateless, that is not concerning about persisting data inside of it, but outside of it to another location. So, and we've seen that we're persisting data in a database, right, for services. However, sometimes we need to run some stateless processes next to our application, so we don't have this luxury of touching the application code. So in those cases, we want to use what Kubernetes gives us in order to help us to manage some processes related to our application, but without touching the application code. So in Kubernetes and in containerized application, actually in general, we have 3 ways of dealing with storage. So there is the container file system, and as its name is saying, you can store persist files or persist anything over there, inside your container. The downside of using such persistence place is the fact that, well, it will stop existing when your container is no longer alive. So it has the lifetime of the container. The second one is the volumes. So volumes are attached to the pods. They are having a lifetime of the pod. And again, pods are also having a limited life. And once they're done, they're not anymore so persistent. And last but not least, the strongest way to persist data inside Kubernetes is using persistent volumes. Persistent volumes are very helpful for stateful applications. And we can talk a little bit more about that at the end of the presentation. So persistent volumes are the ones that are stored at the cluster level, are very strong. They're very difficult to be deleted, so you just need to be very persistent to go and delete a persistent volume. But they're also something that you need to be careful when working with. And let's go a little bit into the code and create such a persistent volume and go with the scenario down the way. So we're going to go to the property, and let's create a volume. So for the volume part, I'm going to make it a little bit. So a persistent volume object, it has also some metadata. We're going to say shared persistent volume 2. We're going to give it a name here, shared volume. And again, the plugin is helping, saying that I'm using something that's deprecated. And I want to access this persistent volume that's at the cluster level in read-write many ways. So I want to read and write multiple times to this persistent volume. And since this is the cluster level, and well, cluster is for everyone, not just for one namespace, but my applications are deployed at the level of the namespaces, I need a way to access in a very elegant manner and in an ordered way my data in persistent volumes. So what I'm going to do, I'm just going to use a persistent volume claim that is giving me access to this persistent volume, the shared PV2. This is going to be called shared PVC2. It also has the access mode read-write many. The persistent volume claim is something that belongs to the namespace. So I'm going to have you can have multiple persistent volume claims, but these are only belonging to the namespace. And another thing that you should know, because in the beginning I also thought that there's many persistent volume claims and one not persistent volume. No, it's a one-to-one rule. So when you're creating a persistent volume, you have also one persistent volume claim and it's accessing that. So the rule would be to use the persistent volumes in terms of storage, like small units of storage, and not to use them, abuse about them. And also, this persistent volume claim has to select the adequate persistent volume, and this one has to go with the name shared volume, the one I have here. So shared volume. And I think I'm done. Let's create this volume here. I'm just going to go to the property again. As always, kubectl apply minus def create volume minus namespace def. Cool. So these were created. Why I created these things? Well, as mentioned earlier, I want to run a process that involves my application, but I don't want to touch my application code. So what I'm going to do is actually I want to try to see that my application is still alive. I could have done that with a liveness probe, but I just want to have this one-off process that I am like, checking that my application is still there, is responding to me. So I'm going to do that by copying some scripts into the persistent volume and running those scripts. So in order to copy my scripts, I just can't copy from local to the cluster like that via the persistent volume claim. I need to attach that persistent volume claim to pod. So I can do that by running a specific script called copy scripts. And this script is having the only scope of just being used to create an adjusting pod for me to copy my local scripts. But also, since I'm creating this as a job, I want to make sure that I'm executing something else. So I just want to make sure that I'm copying the things and I'm getting trace of those things that I'm copying over there. So I'm going to say copy scripts polar, and I'm going to poll all the time the location. I'm going to say here the claim name is shared PVC2. Just want to make sure that I'm just working that shared PVC2. So I'm going to attach my persistent volume claim called share PVC2. And the name is shared volume. And I also have a small mistake here. So shared volume. Okay. And these scripts, they were just looking, this polar is looking in the location shared Greenhouse scripts. So as soon as my scripts are copied here in the persistent volume, then this one dies. It's made its job. So yeah, so I'm just going to create this one in my command line. Simply apply -f, copy scripts, namespace there. And I need to get the pod name in order to copy my scripts. So namespace there. I'm just going to promote to here. And of course, I'm going to copy using the command kbcplcp from scripts to the pod, and the location was, I think, called shared Greenhouse scripts. Just copying it for making sure that copying the thing. Greenhouse scripts minus space there. Cool. So now let me check the logs. It takes some time to need to copy them again. I'll just copy it. Not in namespace. Oh, forgot something. Yeah, so the scripts are copied. And I want to run using the use scripts YAML, shared PVC2. I want to run the script number 1. Script number 1, what it does, well, it's checking the data status of a specific endpoint in my property, I think. It's in the property microservice. So what this does is actually curling for the property service over there, and is just making sure that things are defined. So it just looks inside Kubernetes and is using Kubernetes services. But I want to be able to run the script across namespaces. So I don't want to be preoccupied about the namespace name. So what I'm going to do, I'm going to use the my job namespace environment configuration variable to give it as a parameter for the script. And so I won't worry about what I'm curling across namespaces. And in use scripts, because I need to provide that to my script here, I'm just going to provide it from my use scripts YAML as an environment variable here with my job namespace. And instead of hard coding, like for dev, QA, and whatever I have there, and the value, what I'm going to use the downward API, which is a very nice Kubernetes API for getting values of some already established Kubernetes objects like namespace and everything else that's related to the metadata and describing resources that are well established and well known. So this is a very useful API. You don't have to reinvent the wheel and define own variables and looking at how you're going to provide them and so on. And let me just use my scripts. I'm just going to say kubectl apply, use scripts, namespace dev. Oh, forgot the F. Cool. Let me just get the pods again. I see that the job has completed. So I know that I have some customer data, but my expectation is to see that everything is good in running the script. So yeah, everything went curling, the endpoint, I got some data. So what this was doing, script one was, parsing the JSON, and if it was more than 0 in the JSON, that means there are customers in the database, then the trigger is saying that all is good. If not, it was just saying to me that, well, you have to trigger setup for customers in the database, otherwise this is not going to work for you. So this is an interesting way of, working the application without not even touching the application, just, interacting with it and enforcing a few things on it through scripting. This is just a summary of what I've done so far, just the 4 commands briefly. And the factor 7 is completing, of course, already I stated earlier that in a 12-factor cloud application, an application is being exported as a service via port binding. So what happens is that when we're creating a deployment, an amount of replica sets is being created. So when we're having the specification, it says there is spec 2, spec replicas 2, 1, whatever. Based on the amount of replicas specified over there, you can see the amount of pods that are being created, in this case 2. And this is where your application is going to run in each of these pods. However, if there is another pod, and once again, access to the information and access to the application that is run over here, can do that only by knowing which service to invoke in Kubernetes. So services are very important for gaining access to the information inside of pods. And in order to emphasize the importance of port binding, exposing services in Kubernetes can be done either with the kubectl expose command or either by using YAML definition of that service. So this kubectl expose deployment will result in creating a service object in Kubernetes. And because I haven't specified the port here, it will allocate a random port based on the type of the service. And this type of command can be useful when, let's just say, you forgot to expose your deployment in a declarative way via YAML or via service YAML, or you can use this this command to actually proxy an already existing service. So the kubectl expose command can also be used for services instead of deployment. Here you can use services. If you are, for example, trying to limit the ports or limit in a way access to a certain service, you can use the export command to do that and to make sure that the real port of which your service can be accessed is not exposed later on. The 8th factor is about concurrency. So we have seen so far deployment of the application and everything is working fine and as expected. However, in real life, we do know that there are some stressful situations for our applications when there's a lot of demand on them. So when the workload increases for an application, what it happens is that it has to scale out via the process model. And from Kubernetes point of view, and in order to be in sync with the 12 factors methodology, this happens via the horizontal pod autoscaler. What is the horizontal pod autoscaler doing? So it's looking at the metrics that are being defined by us or wanted by us, and is calculating the replicas that should be managed inside a deployment in order to resist the workload that is wanted from our application. So what this means that these metrics here are being inspected by horizontal pod autoscaler, and then the deployment is instructed to manage the amount of pods. And this can be done in a very automatic way by using the autoscale policy. So the autoscale horizontal policy here in the imperative way, using the command autoscale, kubectl autoscale, can autoscale your deployment by specifying a minimum amount of pods that should exist for that deployment, a maximum amount of pods that can exist for that one, and of course, when another pod should be added to what is already existing there, based on the CPU percentage utilization set by us. So this parameter here, the CPU percent, can can be missed because it's going to be randomly picked and set in the policy. But typically, if you want to have control on how your application autoscales, it's good to set it. And a new pod is being, or desired replicas for a specific autoscaling policy are being calculated using this formula here for desired replicas. This is a very well-known formula. It's in the Kubernetes documentation. So if you're ever trying to see, okay, let's say that minimum pods you can calculate, but the maximum pods, you can always think about what would be the desired metric value for you, what would be also looking at the current metric value, so you can estimate much more accurately based on this formula here. And those being said, let's look a little bit to the autoscaling policy. So I'm going to autoscale the broker deployment, just issuing kubectl autoscale deployment broker, setting min to 2. It was already having 1, maximum to 5, CPU percent to 80 on namespace dev. And because I want you to see the results of what I'm going to do, I'm just going to say to also share this autoscaling policy in YAML format so you can see what is outputting. So this is what exactly is the output of the autoscaling policy. You can see here also the API that's being used. So this is version 1 of the API for the autoscaling horizontal policy. You can see the parameter, the target CPU utilization percentage set to 80, the desired replicas, the current replicas, the desired replicas, and you can see all these things here. So let's look a little bit into the IDE to something I have already here. It's called HPA. So this is similar to what we have. The only difference is that is 80 here. But throughout time, there was a need to tweak a little bit more the autoscaling policy to, gain a little bit more insights and to have much more than just providing one parameter. So in real life, it's unlikely to configure an autoscale policy with the imperative command. Typically, it's being used the YAML, which is a more descriptive way to do that. So by providing metrics and by providing metrics per resource that you're trying to say, that you're trying to autoscale over there. So to gain a little bit more control. So this one is using autoscaling v2 beta 2. And is tweaking a little more, looking at the average utilization, at the resource, and many more metrics of the resources can be tweaked with the autoscaling policy. There's a lot in the documentation, so many more details can be done and can be refined. This is very important for the economy of your application, of your API, because if there are a lot of microservices and they're all having a very aggressive autoscaling policy, it's not very nice for for the overall behavior of your platform. So please bear in mind that there are differences between APIs, but you have access to tweak those differences and to choose what's best for you. So let's go back to the presentation. Now we're seeing about how we handle processes, how we're handling binding, how we're handling concurrency, but we're also interested in how we're going to dispose about applications. We're interested about having applications that are easy to be started and are graceful in shutting down. And the importance of that is not because we are just like playing with the application or start stop. It's because we are continuously doing deployment. So we want to roll out our changes and we want for application to stop very fast and to start very fast and to shut down very gracefully, so you don't have to wait a long time. So imagine if you're using a Jenkins pipeline and there are a lot of, in a big team, you're always going to see Jenkins running something on the environment and like sometimes in the same time. So, well, there's a lot of work over there. So imagine that. You don't want to have an application that is lazy on starting up or shutting down for that. Now, for Kubernetes point of view, the disposability part can be managed with multiple ways. Now, the basics are with the strategy. So in the specifications of Kubernetes, there is a way to specify how you want to, roll out that, that deployment. So there's the recreate strategy. The recreate strategy is depending a lot on application boot time. But in general, an application deployed in Kubernetes, if an application doesn't have very good boot time, adding Kubernetes is not going to make a miracle over there. So always bear in mind that having a good application, good coding application is the one that is main important. The infrastructure is helping, but it doesn't make miracles. And secondly, the recreate, what it does, it stops all the versions of the previous application, and it rolls out the new version. This is a very, let's say, it's a very abrupt way of running your application, but is a very good way to ensure that you're always running one single version of your application. So this is the recreate strategy. The second one is the rolling update strategy. So this is more slowly strategy. It's more recommended, let's say, when you're trying to achieve the zero downtime, because it's rolling update one after another. So it firstly shuts down one pod here, it starts one pod in the second version over here. So everything goes smoothly and slowly to make sure that you are having an app application. But you can get also to the situations when you have pods running different versions of your applications in the same time. So there's always, you have to bear in mind the constraints of how you're going to manage your deployments in order to make that. Sometimes recreate is very good. Sometimes rolling update is not something to dismiss that easily too. So rolling update is highly recommended, to my knowledge, for stateful applications. But since we're not very much looking into stateful applications right now for the 12 factors, mostly stateless ones, we're just going to move along. But always look at the context and look at the importance, what the API says for each of these options. And of course, there is also AV deployments, canary deployments, and all the other stuff. But those don't come out of the box with Kubernetes. They rely a little bit more on your engineering skills to scale up those. We have done a few work so far with 9 factors. But now we're going to look into the beautiful factors related more to our creative part as developers, because we're all creators, right? So the last factors are more concerning us, our development life overall, and so on. So factor 10, the one regarding dev prod parity, even mentioned in the beginning that we want to achieve less differences between develop and production, so we can have continuous deployment. Dev prod parity is achieved by maintaining a good balance between time, tools, and people. Actually, minimizing gaps across namespaces for these 3 is the key of success to having dev prod parity. There is no perfection in terms of achieving continuous deployment, and actually continuous deployment is something that's achieved by trial and error and is built in steps. It's not something that comes out of the box. It's just picked over there and it's going to run by default. There's no such thing as a success. You just take it out from the box and you're just putting over there. It's going to be perfectly working. All the time there's something to be tweaked over it. But for dev prod parity, Kubernetes is very good when it deals with namespaces. Namespaces are places where you are creating resources And you can, you have this bundle of resources that are defining your platform existence. And when, when you're exporting, because there's also the possibility to export your Kubernetes resources from namespaces. Well, if you're exporting the resources from each of your namespace, when you're exporting that in YAML format or JSON or whatever, look at the differences between the resources over there. So if you have objects that are present in one namespace, but they're not present in another one, you should start asking yourself, why? Why don't I need it in another namespace, that resource? Maybe it was forgotten over there. It can happen. It's not good, but it can happen. So all the time, just try to keep them as clean as possible so that you won't end up wondering why that happened. It's also good for the economy overall if you're running application. Factor 11 is looking over the logs. So logs, as you know, from a developer point of view, they're sharing information about, well, that what we have coded with is working, is expected. We're using logs to, debug sometimes, to isolate problems, but mostly logs are good for tracing the state of our application. We can see the peak moments when our application was mostly accessed. We can search through that. We can do a lot of good stuff with logs. By default, in Kubernetes, logs are being stored in the directory /var/log, which is present in every pod. Now, this is very neat and nice. But the thing is that, as mentioned earlier, pods have a limited lifetime. So when a new deployment happens, and well, when that pod is ending its life, well, you might end up losing the logs if you're not streaming them elsewhere. There are a few patterns for streaming logs in the Kubernetes documentation. But if you are wanting the easy way, like I preferred it to in this case, you can stream your logs to an external managed service that exists somewhere else. And how you can stream logs? Well, as in any case with a managed service, you're all the time, having a secret to connect to that managed service. And in order to stream logs from each of the pods here and many more that will come, what I did, I used an already defined daemon set object of Kubernetes. So this YAML here contains a daemon set. When this is created in the Kubernetes cluster, what it does, regardless of how many deployments I will do in how many nodes of my Kubernetes cluster I will do, it will just stream my logs from every place of that one and to the outside service for me to see it in a much more beautiful way. So let me just go here and say kubectl get pod to identify the daemon set, the pod of the daemon set. And this is the log DNA agent. And you can see here that for this one, wait, logs, wait, I didn't copy it. Copy, it's better. Okay, so you can see here that I've kind of started to do a lot of deployments, right? So for all the deployments that I've done, you see here streaming /var/log1 new file. So you see a lot of files here. And of course, if my application is being accessed and things are happening and consumed, but there's a maximum size for my log file, so another log file is being written. What it happens is that each of these log files are being streamed to outside service, and I can search using that service. I can search in the logs, I can trace what went well, and I'm never preoccupied in having traceability of my application. And another great fact about this one, so I'm never gonna lose the information that is here once the pod doesn't exist anymore. So this is a very neat feature of the daemon set. So daemon sets are very good for collecting and streaming data. This is one of the powerful parts. Last but not least, we're gonna do a little demo with the admin processes. So factor 12 is talking about running management tasks as one of processes. So the so-called batch better things. So remember when we used to work with Spring Batch to run something, a very long migration or something very, very important. We used to make that in Java. Well, now we can do that and we can make jobs even with Kubernetes. So I'm going to demo one of these. Firstly, I am going to run my job, but I need to run a script. So I'm going to run script 2. But firstly, I want to store my script. You've seen earlier that I've stored my scripts in a volume, but you can also store scripts if they're small scripts in config maps. So what I'm going to do, I'm just going to create a config map using kubectl create config map. Just going to call it dream home config. And I want to get the information for this config map from file scripts. I'm going to get everything from scripts into the namespace dev, of course, because I don't want to create it somewhere else. And I want to see the information inside that config map in a YAML format. So you see here, this is what I'm having in my config map. It's v1 script 1. The one that we've seen earlier, and script 2 is saying hello from script 2. And this one is actually initializing a database. So if my database will be empty, this script, what we'll do when running this script, well, it will initialize again my my database, one of my databases. I think it's for the broker microservice, for the broker. So it's going to initialize the broker again when being ran. But I need to create a job for that. So I'm going to go here to this one. This is my batch. Okay, so I'm calling it Dream Home Admin because it's running some administration stuff. It needs to run the scripts from the config map that I have configured here and attached it as a volume. So it's going to give a name, Dream Home Scripts volume. It can have whatever name you want. This is not very important, but it has to match the volume mounted here. So these one have to be one-on-one. And the mount path is called Dream Home Scripts. Now, those being said, in my script, let me just go a little bit to script 2. I'm also again using the namespace. So I'm going to get this one as an environment variable from here, using again the download API. And of course, for running my script, I'm going to use the shell command for running the script too. So just going to go here, -f, batch, minus namespace. Yeah. Yeah. And my job has been created. So just go get pod. And if it has completed with success, I'm going to say it's going to show that it is completed. So you see here that my Dream Home admin has completed. Perfect. So let's go a little bit to the presentation. We've been quite a ride, and I think I've already been even more than 1 hour talking here. But some takeaways from the presentation today is the fact that you can decouple the infrastructure complexity from your application code. So you've seen today, I haven't tweaked that much the application code. There, I'm always relying that there's a configuration inside the environment. There's something waiting for me in Kubernetes that I am going to be able to consume and use in my application code, regardless of the values that they have there. But again, you have to very cleanly code your application so that you won't end up with exceptions or other problems when you're getting certain types of parameters from the environment and so on. Secondly, for persistency, always try to put in balance if managed services are a good option for you, or it would be better if persistency would be managed in Kubernetes inside the cluster. So you'd have databases or log services inside the cluster. So even that service, all the services that you've seen there today can be all be built in the cluster in Kubernetes. The downside would be that I have to manage those too. So it depends. There's always a plus and a minus for all of these. And the managed services, when it comes to the cloud provider, is a good thing that the provider is managing those. Always have environment parity and keep your environment as similar as possible for continuous deployment mostly, so that you can propagate those very important changes across environments. And of course, design your application as stateless. So do not try to have state comprised in your application, and not try to store files or anything in the container or something like that, because those are not going to be existing in the second deployment that happens of your application. Thirdly, scale your application via the process model so that it can be able to process diverse workloads. You've seen I've talked about the horizontal pod autoscaler in Kubernetes because we're dealing with stateless applications. The vertical pod autoscaler exists too, by the way. So vertical autoscaling is also possible, but that one is more for stateful applications. Since it was not the concern today, I didn't touch that one. Thirdly, use appropriate logging in application code and implement cluster level logging. So first, you haven't seen today, but you'll have the code at the end in the slides that are going to be shared. So my applications have a custom logger, a logback configuration there. I'm not system outing anything. The reason being is that when, regardless if you're using a managed service to gather your logs or not, logging has to be implemented in an appropriate way so you don't end up losing information. And you need to be able to switch between log levels inside your application. So always be mindful with that when coding your application. And of course, the most important part, because I know keeping a balance between clean code, clean infrastructure implementation, and keeping yourself straight all the time and in development, it can be a little burden. Try to always believe in yourself and that you will succeed in doing that. So this quote here, I love it, I don't know who's the author of it, but it's very, very important. So regardless of the manifests, of the methodologies that exist in the world and the patterns and everything, well, not all of these are valuing much except for you. You can do it. That's the most important part. Thank you for listening to me. Just give me one moment to lighten up. It's almost dark in Romania. So thank you for listening to me. And this was everything from my side. The slides will be shared afterwards. The code is already available on my GitHub. But anyway, there's going to be a link at the end of the slides. Thank you very much for listening to me. Brian, are you over there?
Of course I'm here. I've been listening all the time, and actually, I must say I learned a couple of things because, well, I'm not quite a big user of Kubernetes and Helm. I'm just more like a hobbyist that tries to do these things. And well, these 12 factors and the way you build up these things are interesting. And I actually had a question from somebody who asked, like, you were autoscaling these. You were autoscaling Kubernetes based on the CPU, right?
Yeah.
Is it possible to autoscale on other things? Because somebody asked, like, things like throughput or something to schedule throughput to different parts.
So there are a series of resources that are available through the API. That's what I just showcased, the V1 API. There have been some improvements, as I've shown, is the V1 beta 2 and V2 beta 2. There's different betas, but most of the things that can be tweaked in the autoscale, those metrics are available in the documentation of Kubernetes, and you can specify more, but you don't specify them imperatively in the command line like I showed there. You're doing it in the YAML like I show later on. So you have to do it declarative and tweak those declaratively. And typically, everything is being managed declaratively because commands belong to scripts, but even infrastructure, even code that is used for infrastructure needs to be seen in a very neat way in a file, a structured code file. You understand a little bit more in the YAML from a YAML file than from a command with certain parameters. Come on. So yeah, there are some other resources that can can be, customized. You can make, I've seen that there can be done some custom metrics. I haven't tried those, but there are a lot of things available more than the CPU utilization. That's just the basic. That's the basic that you can see, but you can tweak a little bit more. And if you play with the IntelliJ plugin for Kubernetes, you can see a little bit of those, but you still need to know a little bit of the API so that you can know what part of the resource you can customize. So yeah, there's much more of that. And of course, the rule for, getting to the desired replicas, the mathematical formula I showed, yeah, well, that one changes a little bit based on the amount of metrics that you're configuring over there. So yeah, that's the easy way of explaining things.
All right, thank you. Well, that's basically the end of our session for today. Thank you, Anna, for doing this. I appreciate it very much, and we had some great great reactions. People liked it a lot. So thank you. Thank you for that. The next session is not yet known, but keep track of our website, virtualjug.org, our Twitter handle, and of course we will broadcast everything on YouTube. If you are watching this like afterwards on the video and you still have questions, feel free to ping in the Slack channel, or well, you can ping Anna directly on her Twitter handle. From this part, Anna, I want to thank you again, and I want to say goodbye to every single one of you. Thank you for watching, and see you at the next. Yes, of course. I hope this will not be the last time to have you here. So thanks again. Thanks for watching, and hope to see you at the next feature session. Thanks. Bye-bye.
Bye.